This conference will now be recorded.
Hmm. So we'll be starting our next topic, that is preventive maintenance. Okay. So the topics that we are going to cover, they are, we will see the preventive maintenance overview. We'll understand what is preventive maintenance basically, different types of preventive maintenance, what are the different types of preventive maintenance available. Okay. Preventive maintenance process flow, how the preventive maintenance process works. Okay. What is the end-to-end process flow, we will see. Then we will understand maintenance strategy. What is maintenance strategy? Importance of maintenance strategy, why the maintenance strategy is used. Okay. Then types of scheduling indicators, their significance. Then we will understand call origin and shift factor. Okay. Then maintenance packages. What are maintenance packages? Why they are used? Importance of hierarchy. Okay. What is hierarchy and why it is used? Then we will today will create both time-based maintenance strategy and performance-based maintenance strategy. We will create both today. Okay. So first we'll start with the preventive maintenance overview. Okay. So basically, in the organizations, to minimize downtime and repair cost, equipments in the company are checked and maintained at regular intervals. So normally, in any manufacturing company, to produce the products, they will use some machines. So these machines, at a regular interval, what they do is they will do some maintenance activity. Okay, like every 1 month, after every month, or after every 6 months, or after, in some companies, after every 1 year, they will do some maintenance activity. That activity is called preventive maintenance. Okay, even though equipment is in good working condition, still they will do some activity like cleaning the machine, applying the oil and grease, changing the critical spare parts. So these activities they will do. So that maintenance activity is called as preventive maintenance. Okay. This basically, so why we need to do preventive maintenance? So we need to do preventive maintenance to reduce the breakdown time. Okay. The objective of preventive maintenance tasks is to prevent the system and other technical objects from a breakdown. The technical object is nothing but normally your equipment. So the main purpose, the main idea of carrying out preventive maintenance, just to ensure that machine doesn't have any breakdown. Okay, it is same like your when you purchase a two-wheeler or a four-wheeler, the showroom guy will ask you to come for servicing. Okay, after 1 month from the date of purchase, initially, and later on, what he says, you come for every year for servicing. Suppose let's say you purchase a four-wheeler car, then the showroom guy will ask you to come for servicing every year. So that is more or less like preventive maintenance. Okay, three types of preventive maintenance is performed. One is based on time. That means tasks are triggered after a specific period is elapsed, like every 6 months. That's what I just explained. Okay, they do preventive maintenance after every 1 month, or after every 6 months, or after every 1 year. It depends. That is time based. Next one is the performance based, based on performance. This is also called as counter based. Okay, tasks are due when a specific level of performance has been reached, like every 10,000 kilometers. Example, suppose let's say you have a car. Okay, there is a normally what they do, after the car reaches 50,000 kilometers, they will change the tires. Okay, so that is like a counter based. Okay, suppose let's say in the machine, in the organization, in the machines, after the machine runs 10,000 hours, they need to change some spare parts. So all those comes under performance based. It is also called as counter based. Okay, and the last one is a condition based. Tasks are due when a condition is outside a specific value range. For example, a thread depth below 15 minutes, or temperature higher than 85 degrees centigrade. So this one, you expect your equipment to have certain conditions, like let's say temperature. Temperature should be between 0 to 80 degrees. Equipment temperature has to be between 0 to 80 degrees. Suddenly the temperature is showing 85. So then there's a problem. So then you have to do preventive maintenance. So this is based on condition. Okay, so basically you have three types basically. Okay, time based, performance based, this is also called as counter based, and another one is condition based. Okay, and this preventive maintenance which we are discussing today is a planned maintenance. Okay, the maintenance processes which we discussed earlier, a regular maintenance, breakdown maintenance, they are unplanned. Suddenly the machine will be under breakdown, suddenly the machine will be having some problem, so then you do repair activity, that is unplanned. But this preventive maintenance which we are discussing today is a planned maintenance. You know already when you are going to do maintenance, that's why it's a planned maintenance. Okay. Uh, so now we'll discuss about the process flow of the preventive maintenance. First, here they will identify the tasks in a task list. So during the preventive maintenance process, what tasks we need to perform, what operations, what activities we need to perform. So that they will put it in the task list. Okay. After that, they will create a maintenance plan. This maintenance plan will contain what is your total duration of preventive maintenance, what is the cycles, okay, and on which equipment you are going to do, from which date you are going to start preventive maintenance. All these are maintained in the maintenance plan. Okay. After that, they will schedule this maintenance plan. When they schedule this, once that particular time period is reached, once that particular criteria is reached, system automatically creates maintenance order. So in the preventive maintenance, the order will get generated automatically. In the previous processes, regular maintenance and breakdown maintenance, we created order manually. But here in the preventive maintenance, from here onwards, the order will get generated automatically. No need to create manually. And once the order is generated, it's an outstanding order. Then you know the process. We know the process. Once order gets generated, you release the order. Okay, and if during the release of the order any permits are there, you will issue the permits. And then once the maintenance activity is completed, you confirm the order, and then technical completion, and then finance activities will do their activity. So that part remains same. Only the order generation is automatic. Okay, so from here onwards we need to understand how to generate the order automatically. What data setup, what design we need to do in the system, we need to understand. Okay, so this is the setup you need to do. First, you need to create the maintenance strategy. Okay, we will discuss subsequently what is this maintenance strategy, why it is used, all those things. Then this maintenance strategy is assigned to the task list. They will create task list. Tomorrow we will go to this task list. And then once the task list is created, then they will create the maintenance plan. In this maintenance plan, they will assign the task list. Okay, and when the maintenance plan is scheduled, okay, automatically system generates a order, preventive maintenance order. So this is the whole design we need to do. We need to create strategies, then task list, then maintenance plan. All these are assigned to each one. Strategy is assigned to task list assigned to maintenance plan. Then when it is scheduled, orders will come. So in the next coming 3-4 classes, we will see this entire setup. Okay. So now the first one in the preventive maintenance process is normally creating the maintenance strategy. Okay, so now we will talk about maintenance strategy. Okay, so maintenance strategy defines the frequencies and represents the scheduling rule for preventive maintenance. So in the maintenance strategy, you will maintain your cycles. Cycles, nothing but packages. Cycles are nothing but the packages. Frequencies, in what interval, what activity you are going to do. That intervals you will define. Frequencies, packages. Okay, it provides flexibility of scheduling based on several conditions. I will show you this in the system. Okay, defined once and then used in linking task list and maintenance plans. So this is the strategy which we are going to create, ultimately used to link your task list and maintenance plan. This we will see when we go to these particular topics. Okay, now it contains packages as counter milestones. So basically maintenance strategy will contain the packages. cycles, frequencies. Okay, it can be set according to time based, or and according to equipment performance, counter based. Okay, so there are two types of maintenance strategy. Either you can create time based, or you can create performance based, nothing but counter based. Okay, why we need to create this strategy is, suppose for example, in your company there is a water pump. There is a water pump. Okay, so for this water pump, what they do is, every month, every month, they will do the external visual inspection for rust. They will check for the rust every month, whereas they will check wear in gearbox of the pump once in a year. So in different cycles, they are doing different activities. Every month they will check for the rust, and once in a year they check for the wear in the gearbox of the pump. So that means different cycles they are doing different activities. So due to this one, we will be using the maintenance strategy. Okay, so this is the one. So why we need to create the strategy is, for the same equipment, for different cycles, they will do different activities. Suppose, let's say, after every month they have to do external visual inspection. After every 3 months they have to do internal visual inspection, and after every 1 year they have to check for the gear teeth for wear in the pump. So different cycles, different activity. If that is the case, then we have to create maintenance strategy. Okay, so first we will start with the time-based maintenance strategy. Okay, so there are two things here. Okay, maintenance strategy. One is time-based. Next one is performance-based. Performance. Okay, we will create both. First we'll start with the time-based maintenance strategy. Okay, so here, this is the one. Let's say you have a pump in your organization. So for this pump, every month they will do external visual inspection. After every 3 months they will do internal visual inspection, and after every 1 year they will check for the gear teeth for the wear. Okay, so here it is based on time. So then you have to go for time-based maintenance strategy. Okay, so this strategy, time-based strategy, in this time-based strategy you will maintain the scheduling indicator. Okay, and strategy unit, call origin, shift factors, and factory calendar. Okay, we will discuss all these things one by one. So first let's go and create a time-based maintenance strategy. Okay, let me log into the system. Okay, I logged onto the system. T code to create the maintenance strategy is IP11. I will show you the navigation part. Okay, go to logistics, open the logistics, go to plan maintenance, open this. Here, preventive maintenance, you have a folder, preventive maintenance, open this. Maintenance planning, open this. Okay, here you have maintenance strategy, open this. IP11. Okay, double click, this is the T code. Okay, you already have some strategies, but let's create a new maintenance strategy. Click on the button new address. Here you give the name HYMT, Hyundai time-based. Okay, time-based Hyundai automobile. Okay, so time-based strategy I'm creating. So now here you have scheduling indicator. So what is the scheduling indicator? If you see here, you have 4: time key date, time factory calendar, and activity. So now we will understand this scheduling indicator. So what is the scheduling indicator? Okay, scheduling indicator provides flexibility of scheduling based on several conditions. First is time. If you select a time, dates are calculated in calendar days exactly after the interval. Okay, if you select time key date, the dates are calculated from the cycle start always for the respective key date. Now if you select time factory calendar, the dates are calculated in working days only. Okay, so I'll just explain with a simple example. Suppose let's say your cycle is 30 days. For every 1 month you have to do preventive maintenance. So if it is 30 days, if you select time, if you maintain time, what happens is, if you maintain time, let's say your current date is 21st of August. Okay, now your cycle is 30 days. So next preventive maintenance will be due on 20th of September 1999. That means after 30 days. That's all. Whether it is a working day, holiday, public holiday, it will not check. It will consider all the days, and after 30 days, after 30 calendar days, it will create the order. Okay, sometimes 1 month can have 30 days, 1 month can have 31 days, 1 month, suppose sometimes in February you have only 28 days. It will not check all those things. Exactly after 30 days, it will create a order. Okay, so that is time. Now time key date. Time key date means if you put the first starting date as 21st August 999, okay, your cycle time is 30 days. Exactly on the same date after the next month, it will create order. So here you see 21st of August, next one 21st of September, next one 21st of October, next one is 21st November. If you select time key date, exactly on the same date. Now, if you use time factory calendar, what happens is system will use only 30 working days. It will exclude holidays like Saturdays, Sundays, any public holidays like Christmas, what do you call, what do you call, Good Friday, or in India you have this Diwali. Okay, all these festivals, public holidays, and weekly offs, Saturdays, Sundays, it will exclude, and it will take only 30 working days. After 30 working days, it will create the order. So here you see time factory calendar, normal time. You see the difference. If you use normal time, it is 20th of September. But if you use time factory calendar, it is 2nd October. Because in between the holidays, weekly offs, okay, public holidays are excluded. That's why there is a difference. So these three you need to understand. Okay, so time key date, time factory calendar. Okay, so here what we selected, as of now I will select time. Okay, we discussed time key date, factory calendar. Activity will be used in performance based, counter based. Okay, so let me go ahead with time only as of now. Okay, next, strategy unit. What is my strategy unit? UOM, basically time, whether you want to have months, weeks, days, years, which one you want to have. Strategy unit, I'll select, put it in days. Click on the list. Got disconnected. Okay, let me log in again. Might have got disconnected. Wait. Okay, IP11. Okay, click on new entries, give the code, description, scheduling indicator. As of now, I'll take time. Okay, we discussed already the difference between these three. Next, my strategy unit. Okay, if you click on the list, you will get all these things. I will use days. Day. Here you see days. My cycle is in days. Select days. Next, call origin. We will understand what is this call origin. Okay, call origin. Call origin. The call origin is used to define when the maintenance call object is generated compared to the planned date. Okay, when the maintenance order has to be generated. Okay, suppose I'll tell you, you have to do preventive maintenance on a particular day. On the same date, the order got generated. Then the planner will complain. You are generating the order on the same date. I don't have time to plan my activities. You need to give me 2-3 days time to plan my activities. That means order has to generate it 2-3 days in advance. Okay, suppose let's say you want to do preventive maintenance. Let's say today, what is that? December 12th, right? Let's say there is a preventive maintenance due on 10th 12 2021. On this day, preventive maintenance has to be done. But on the same date, if the order is generated, for the planner, there is no time to plan his activity. He says you generate the order, let's say 2-3 days in advance, like 07 012 2020. So on this date, order will get generated. Order generation date. Okay, but actual preventive maintenance date is on 10th of December. Preventive maintenance date. On that day, you need to do carry out preventive maintenance. This is the date. Okay, so there is a cushion time, buffer time of 3 days to plan the activity. For this one, they will use the call origin. Okay, always remember the call origin is specified as a percentage of cycle. Okay, if I show you this, suppose your cycle is 250 days, let's say. Okay, and if you define a call origin as 0%, 80%, 100%, okay, then what happens is, if you put call origin as 0%, order will get generated immediately. Okay, and if you put 100%, on the order will get generated on the exact preventive maintenance date. Then your order date, call date and maintenance date both will be same. Order will get created on the same date. And if you maintain 80%, then it will become 80% of your cycle time. So your cycle time is 250 days. 80% of 250 days is 200. That means after 200 days, the order will get generated. There is a cushion time of 50 days. Okay, if you see this one, you will understand better. Suppose if you see here, my cycle time is 3 months. Okay, after every 3 months, I want to do preventive maintenance activity. Okay, 90 days. Let's say if I maintain call origin as 90%, 90% of 90 days, how much? 81 days. That means order will get generated on the 81st day itself. And your preventive maintenance will be due on 14th. Suppose if you see here, my startup cycle is on 15th of Jan. My cycle time is 3 months. That means I have to do preventive maintenance on 14th of March. Sorry, April. 14th of April. Okay. So this is 90 days. But if I maintain call origin 90%, 90% of 90 days, that is 81st day. On the 81st day itself, the order will get generated. That is on the 5th of April. So there is a cushion time of 9 days for the planner to plan his activity. I'm repeating again. Call date is the date on which your order will get generated. Planned date is the date on which you are supposed to carry out preventive maintenance activity. So this call origin is basically to give the cushion time for the planner to plan his activities, like checking the spare parts availability, checking the technicians availability, or some other availability he has to check, right? So for that, he will use this buffer time, cushion time. That's why they use this call origin. Normally in the real time, they will maintain call origin as normally 90% or 80% based on my previous experience. Normally. Okay, so that is a call origin. Here you maintain the call origin, so I'll maintain 90%. Okay, understanding the concepts is very important. Interviews, they will ask this question: what is call origin, why it is used? Then they will ask scheduling indicator, what is the difference between these three? They will ask this. Okay, nobody will ask you the T codes in the interviews. Okay, so that is a call origin. Okay, next we will discuss about shift factor. So here you have the next one is the shift factor. Here you see there is a shift factor for late completion, shift factor for early completion. So normally most of the time in the industries they use shift factor for late completion 50%. I'll put 50%. Okay, I'll tell you what is this shift factor for late completion. Okay, shift factors are defined in the maintenance planning component for premature completion or delayed completion. Okay, you can define the shift factor specifically for your maintenance plan by specifying the shift percentage to be considered when calculating the next due date. Okay, suppose your preventive maintenance is due on 1st of August. Okay, but on this day you are supposed to do preventive maintenance, but due to various reasons it got delayed by 15 days and you did the preventive maintenance on 16th of August. So how many days of delay? Delay is 15 days, correct? Delay is 15 days. Now if you maintain shift factor as 0%, then your maintenance order will get generated exactly as per the cycle. So your cycle time is 30 days. So next, if you maintain shift factor, it will get generated exactly on the 1st of September after 30 days. So it will not consider this delay. But if you maintain shift factor as 100%, then it will shift the next order by 15 days because the previous order got delayed by 15 days. So the next order also will get delayed by 15 days because 100%. Now, if you maintain shift factor 50%, then your next order will get delayed by 50% of previous delay. So previous delay is 15 days. 50% of 15 days is 7.5 days. So if it is get rounded, it is 8 days. So next order will get delayed by 8 days. Okay, if you see this, you will understand in detail. Okay, suppose your cycle time is 3 months. Okay, 90 days. Now your shift factor is 100%. Okay, now you started your preventive maintenance on the 15th of March. Okay, so 3 months, your cycle time is 3 months. So next preventive maintenance is due on 15th of June. But due to various reasons, it got delayed by 15 days, 15-day delay. So you did the maintenance on 30th of June. Now, as the shift factor is 100%, your next order also will get delayed by 15 days. System automatically shift the next order by 15 days because it is shift factor is 100%. But if you maintain here 50% shift factor, then this order, next order will get delayed by 8 days. 8 days. 50% of 15 days. 50% of 15 days delay, how much? 7.5 days. Rounded off to 8 days. That is the use of shift factor. Okay. So now let's go here. Let's maintain here shift factor. Okay. I'll maintain as 50%. Normally in the real time, normally they use shift factor for late completion. Shift factor for early completion, normally they will not use because nobody will carry out preventive maintenance early normally. But if you want to use, you can use that one. So 50% early. Okay. Now you have tolerance for late completion. So we will understand what is the tolerance for late completion. Okay. Now tolerance defines late or early completion time period and the impact it has on the planned schedule. Plus tolerance is set for late completion and minus tolerance is set for early completion. Okay, suppose the smallest cycle in the maintenance strategy which you have assigned to the maintenance plan is 30 days. Okay, so normally let's say your cycle time is 30 days. Okay, now you have defined a tolerance of 10% in case of early completion. Then this produces a tolerance of 3 days. So if your activity is completed not more than 3 days, then system will not do any shifting. Okay, suppose if you see this, you will understand. Okay, suppose your shift factor is 100%. Okay, shift factor is 100% and your cycle time is 30 days. Okay, so your preventive maintenance started on this date. Next preventive maintenance has to be conducted on this 31st of August. But due to various reasons, they completed preventive maintenance on 24th of August. 7 days in advance. Then the next order also will get shifted by 7 days. Okay. So here, if say they maintain tolerance of 20%, 20% is 6 days. If it is just delayed by completed by 6 days, then there will not be any shifting. So this is the tolerance. Out in that shift factor, you are giving some tolerance. So if it is completed in earlier 1 day, 2 days, 3 days, 4, 5, up to 6 days, there will not be any change in the new date. But if it is completed more than 6 days, earlier more than 6 days, let's say 7th date, then the next order also will get shifted. That is a tolerance. That is a tolerance. Okay. So now here I can put my tolerance as, okay, this I will put it as 100%. Tolerance I'll put it as 20%. Okay, for late completion. Normally for early completion they will not use this. Okay, that's okay. Next one is a factory calendar. Factory calendar is normally the calendar which contain working days, holidays, all those things. When I go to factory calendar configuration, I will show you that. As of now, let me assign some factory calendar. I think again it might have got disconnected. Okay, let me log in again. Okay, let's go to IP level. Click on new entries, name, time, strategy. Okay, call origin 90%, shift factor lead completion 100%, and tolerance I'll put 20%. Early completion also you can enter, that's okay. Now factory calendar, I will put it as 01, Germany standard. Okay, so this factory calendar will contain all the working days, holidays, weekly offs, public holidays, it will contain. Okay, now we enter this data. Now we need to go to packages. Packages are nothing but cycles. Packages are simply nothing but cycles. Okay, so 1 month, 3 months, 6 months, all these are called packages. So now we need to enter the packages. So on the left side there is a folder, packages. Click on that folder. Taking a lot of time. Okay, so now we are into packages. Click on new entries. Now here you have to give your packages. Okay, so I'll do one thing. I'll just copy from a Excel file just to save the time. I'll copy from a Excel file. Okay, this is the package number. Cycle length is 15 days. Unit, it's text, cycle short text, and hierarchy. I'll come to this hierarchy in a minute. Okay, so I can enter one by one. You can enter one by one, but just to save the time, I will enter from the Excel file. I'll copy from the Excel. Okay, so this one I'll put. This is the package number, cycle number. This is the actual cycle length. Every 15 days, I want to do certain activity. This is a unit of measure. Give the cycle text. This is a cycle text. I'll copy all at once. Done. Okay. So here the meaning is for every 15 days, I want to do certain activity. For every 30 days, I want to do certain activity. Every 90 days, that means after every 3 months, I want to do certain activity. This is the cycle length. This is the unit. cycle text. Okay, this is the short text again. Cycle short text, 2 weeks, 1 month, 3 months, 6 months. It then hierarchy. We will discuss about this hierarchy in a minute. Okay, so now for the time being, I'll save this. I'm saving this. So now your strategy, maintenance strategy is created. Time-based maintenance strategy is created. Okay, so now we'll discuss about hierarchy. Suppose if you see here, I maintained hierarchy as 1, 2, 3, 4, 5, 6. Okay, and this hierarchy short text H1, H2, H3. What is this hierarchy? We will understand. The hierarchy of a maintenance package defines whether all maintenance packages that coincide should be executed or whether certain maintenance packages should be ignored. For this reason, a higher level is assigned to each maintenance package. Okay, if maintenance packages with same hierarchy level coincide, all these maintenance packages are executed. If maintenance packages with different hierarchy levels coincide, the maintenance package with lower level is not executed. Okay, I'll tell you the real-time example. Let's say you are doing maintenance for a two-wheeler vehicle. Okay, now the criteria is the spark plug should be cleaned every month. Every month they have to do maintenance of two-wheeler and they have to clean the spark plug every month. Now these spark plugs should be changed after every 6 months. Every 6 months. Now, in order that cleaning and exchanging are not both performed after 6 months, the 6th month package is assigned a higher hierarchy than the 1 month package, whereby latter is deactivated. That means on the 6th month, anyhow you are going to replace the spark plugs, then what is the point in cleaning? So you don't clean on the 6th month. First month you clean, second month you do the cleaning, third month you do the cleaning, fourth month you do the cleaning, fifth month you do the cleaning. But on the 6th month, anyhow you are replacing them. No need to clean that. So on the 6th month, you will not perform 1 month activity. So that is hierarchy. If you see here, this is the one. Suppose let's say you have two cycles, 1 month cycle, 3 month cycle. If you assign same hierarchy to the two cycles, then on the third month you will execute both. On the third month you will do 3 months activity, 3 months maintenance and 1 month's maintenance. But suppose let's say you use different hierarchy levels. Okay, so 1 month activity is having hierarchy H1, 3 months activity is having hierarchy H2, higher level hierarchy. Then on the 3 months you will do only 3 month activity, 1 month activity you will not do. So that is the importance of the hierarchy. Whether you want, when the packages coincide, whether you want to execute all or you want to execute only the higher level one, that is decided by this hierarchy. This is also the interview question. In the interviews they will ask this question: what is the importance of hierarchy? Okay, so in my case, in our case, if you see, I maintained higher level of hierarchy, correct? So now if you click on this button, package sequence, see, what do you observe? We have higher level of hierarchy. On the 15th day you do 2 weeks maintenance, but on the 30th day you will do only 1 month maintenance. 2 weeks maintenance you will not do. The reason is this is having higher hierarchy. On the 60th day you will do 1 month maintenance, that's okay. But on the 90th day, see, actually you are supposed to do 2 weeks maintenance, 1 month maintenance, 3 month maintenance on the 90th day. But as there is a higher level of hierarchy we are using, on the 90th day you will do only 3 months maintenance, because we have higher level of hierarchy. Suppose I'll go back, I'll make all one now. Now you see the difference. Okay, sorry, this 1, 2, 3, 4, 5 only. Okay, this one I'll put H1, all H1 only. Save once, go to package sequence. Sorry, Sorry, I got confused. This we need to maintain one. Sorry, this is short text, right? This remains same H2. Sorry, I put wrong thing. Okay, now all are having same level of hierarchy. Okay, let me save this once. Now you see, if I go to package sequence, now what difference do you observe? On the 30th day, you do both. And on the 90th day, after 3 months, you will do all the three: 2 weeks maintenance, 1 month maintenance, and 3 months maintenance, because all are having same level of hierarchy. Okay, so that is the importance of the hierarchy. The client will decide which one they want to do, which one they want to follow, higher same hierarchy levels or different hierarchy levels. Okay, anyhow, I'll put different hierarchy levels. Let me go back again. I will put different 2, 3, 4, 5, and 6. Done. Save it. Now again you see the difference. If I go to package sequence, now you see the difference. See, that is a difference. Okay, so now we discussed about the packages. Okay, so now let's discuss about this package. This is the package number. 10, 20, 30 is the package number. This is the cycle length, cycle length, cycle length. This is its description, and there will be a unit of measurement. Unit of measurement is nothing but days. This is the cycle short text. There will be a short text. Okay, and hierarchy. I already explained you on the hierarchy. What is the importance of this hierarchy? And we have offset. This offset we will discuss when we go to the schedule. Ultimately, this strategy is assigned to plan, and when they schedule the plan, that time I will show you this offset. Okay, now see. So this is how you create the maintenance strategy. Okay, now other than this, we have one more: performance based strategy. Okay, counter based. Suppose, let's say in your company you have a pump. Okay, pump. So you, after the pump consumes 10,000 liters of fuel, you have to do external visual inspection. Okay, and after it consumes 50,000 liters of fuel, you have to replace the seals. Okay, so you have different cycles here. So in this case, you go for performance based maintenance, nothing but counter based. Okay, so for that, I'll create a strategy. Let's create one more. So we created time based, then we are creating performance based, nothing but counter based. Counter based. Okay, counter based. So let's go back. Same transaction. Go back. Okay, go back. Very slow. Not sure what's the problem. Okay, now let me create one more. Click on new entries. Now we will create performance based P. Okay. Performance based Hyundai Auto. Now here scheduling indicator by default active. Okay. So now when you are creating a performance based strategy, you cannot use this time key date, time factory calendar. You have to use by default activity. Okay. Now strategy unit. Let's say here I will take it as what do you call hours. I want to do it based on the machine running hours. If you click on the list, you will have hours. So based on my machine running hours, I want to do preventive maintenance. So my unit is hours. Call origin, we already discussed 90%. Shift factor for late completion, I'll put 100%. Tolerance, I'll give just 20%. And a early completion, I'll just give 50%. Normally in the real time, they will not use this. SAP has given this option, but early completion is very rarely used. Now enter. The moment you enter, see, factory calendar is grayed out. See, factory calendar is grayed out because it is not based on time. That's why in performance based, factory calendar is not used. You see, it got grayed out. Okay, now go to packages, double click, click on new entries. Now here you will enter your cycles. Now here you need to enter your cycles. You can enter one by one. Just to save the time, I'll copy from my Excel file. Okay, that means here after every 500 hours of my machine runtime, I want to do certain activity. After 1500 hours, I want to do certain activity. So these are my cycles. Now give the remaining things. Cycle, short text, hierarchies, all those things you give it here. Enter. Actually, my system is very slow today. But this is S4 HANA system. It's okay. Okay, let me save this. Got disconnected or okay, got saved. That's all. Go back, go back, go back. Now we created two. One is time based, one is performance based. We created two maintenance strategies. One is time based, one is performance based. This we will use in the subsequent classes. Okay. So with this, we are done with the maintenance strategy. Maintenance strategy. Okay.